Hello class, this is Mrs. Albritton of Albritton's Math Class AMC. Now today we're going to be taking a look at the study guide for our first unit test, which is on data and statistical reasoning. You have the study guide, it has been uploaded into Canvas, and we will get you a hard copy if you need a hard copy of that. Let's take a look at number one. Here we've got a company that surveyed 1,000 of its employees and discovered that 65% enjoy working remotely. Identify the population. Now we've talked about population as opposed to sample size. We found out that population would be the entire set, for example, the entire United States, the entire school of Westlake. Well, a sample may be the freshman class of Westlake High School, or it may be the female population of the United States. So we're looking at just the differences between those. Let's look at the answer choices. So A wants to know if the population, this is what we're looking for, population, is all the employees in the company? Is it 65% of the 1,000 employees? Is it 1,000 employees in the company, or 65% of all the employees? And in talking about what population and sample mean, we would go with choice A, all the employees in the company, because that's the entire population. Now this doesn't say that a company surveyed all 1,000 of its employees, so we can't assume that there's only 1,000 employees in the company. It looks like they just chose 1,000 of the many employees that they may have. So in this case, population would be choice A. Number two, decide which study is an experiment. And we talked about the difference between observational studies, we talked about surveys, things like that. But when we're talking about an experiment, we're talking a little bit more in depth. We're looking at independent variable, dependent variables, things that can be manipulated by the actual person conducting the study. So let's take a look at which one fits that mode. So A, we've got a student taking a poll of how many students would prefer to have mandatory uniforms or not, and why they feel that way. Okay, so I see here there's a poll, trying to find out some information about the students. I don't see necessarily independent and dependent variable that we can actually do some things with, that we can manipulate or try to have them fit into one mode or another. So I wouldn't go with choice A. B, a pharmaceutical company is testing a new drug to lower blood pressure. They recruit 200 participants with high blood pressure and randomly divide them into two groups. Group A gets the new drug, Group B gets a placebo. We talked about a placebo being sort of like a sugar pill, something that actually doesn't have any active ingredients in it, but we're led to believe that it does. Let's see, after 6 weeks, the participants' blood pressure is measured. Now, I'm leaning towards B right now because I see some different variables, independent, dependent variables that we can actually do some things with the placebo and the actual active pill. So we're doing some kind of manipulation. We're giving one group one, the real pill, and the other one something that's a placebo. And then we're gonna study the effects of both of those without letting them know. So I would go with choice B. Now choice C just said a school system had a random sample of 150 students. They did an interview, they took a survey. So that's not an experiment, according to the definition of experiment. And a group of scientists survey a group of adults to see how their diet's related to cholesterol. I don't see any independent or dependent variables here. So for this one, we would go with choice B. 3. A city has 10,000 registered vehicles. The local government wants to conduct a pollution survey and collect data on vehicle emissions. The sampling will start with a random chosen vehicle from the first 100 vehicles, and then every 100th vehicle thereafter will be included in the sample. We need to identify the sampling technique that they use. We talked about 4 different sampling techniques. We talked about stratified and cluster. And remember with those two, those are the two where we actually group different sections. But then for the stratified, we take just a few random samples out of every group. With cluster, they're also grouped, but then we take an entire one of the groups, everybody in that particular group or more groups. But we don't just take a sample out of every one like we do with stratified. The random sampling is when there's actually no method that we're using, we're just randomly choosing different subjects. And systematic is when you start with some person or item, some entity, and then you systematically choose maybe every third, every fifth, so the third one, the sixth one, the ninth one, the 12th one. So you've got a system in place. And this one sounds like it's systematic because we start with the first 100, and then they take the 200th, 300th, 400th, 500th. So every 100th vehicle is taken. So that's systematic. Number 4, the scores on a math test are normally distributed with a mean mu, this is the symbol for mean, of 75 and a standard deviation sigma, that's the symbol for standard deviation of 10. If a student scored 85 on a test, what is their z-score, and explain what it means. Now I want you to recall that the formula for z-score is z is equal to x, and x is some data point, and in this case the data point from the list is 85, minus mu, which is the mean, divided by standard deviation. So here's Desmos. So I'm going to go ahead and put in the data point of 85 minus the mean of 75 divided by the standard deviation of 10. So let's type that in Desmos and let's get our answer. I'm going to use parentheses to group the numerator of 85 minus 75, close parentheses, and then divide by the standard deviation of 10. And notice that our answer is 1. So when we go back to the problem, let's go back to the problem and take a look at the answer choices. Since we got 1, when we put this in Desmos, our answer is C. The z-score is 1, which means the test score is 1 standard deviation above the mean score.